All right. Welcome, everybody. So excited to welcome you all to today's Technical Talks webinar on Build a Delivery Tracker with live location and ETAs. My name is Jody Rosenblum, and shortly I will be introducing you to our speakers here. Connecting the digital and physical worlds is more important than ever today. Industry-leading organizations like Whataburger, American Eagle, Dick's Sporting Goods are all shaping the way that location plays an important role in delivering unforgettable digital experiences. So today's Technical Talks is going to be a deep dive for the builders, for you guys, the product and engineer teams, presented by our own location experts and builders, to explore how you can build better customer experiences with accurate trip tracking like ETAs and arrival detection. So it is my pleasure to introduce you all to today's presenters, Pal Makkar and Arek Sokol. Pal is Radar's senior product manager, where he heads up trip tracking features, capabilities, and product roadmap. Prior to joining us, Pal was at Uber as a product manager, working on marketplace dynamics and spending time with Yelp's engineering team as well. Arek is Radar's senior solutions engineer, where he helps product and development teams build location-based experiences. With over 3 years here on the team, Arek comes with a wealth of knowledge from leading organizations like Apple, Genentech, Salesforce, and more. Most recently, Arek served as principal solutions architect and lead sales engineering teams at Informatica, an enterprise cloud data management platform. A couple housekeeping things here. We will have a Q&A at the end of this webinar, so please use the questions box on the side panel to submit any questions anytime throughout this presentation. And wanted to let you all know that this webinar is being recorded, and so we will follow up with you guys afterwards with a recording of the session. So with no further ado, I will let you guys take it from here. Pal and Arek, I'm excited to introduce you both.
Thanks, Jody.
Thanks. I'm going to share my screen, and we're excited to kind of walk you through some of the an introduction to Radar, and then we'll get going with the tutorial as well. There we go. All right, Arek, off to you to kick it off.
Awesome. So just to quickly jump in and give everyone an overview of Radar. So Radar is location infrastructure. So when you're thinking about all your pickup locations, your facilities, wherever you may be tracking, whether it be drivers or customers too, all right, we provide the foundation for allowing you to generate as many geofences based on an address, based on coordinates, that you could bulk load without any limits for those destinations. With that, we provide technologies like trip tracking that allows you to leverage our SDKs, our APIs to monitor these trips, to generate events, know when someone's approaching, know when someone's arrived, and utilize those signals to power dashboards, analytics, whatever is important for you. And then we also provide APIs, which also play a critical role in the sense that you may have an address and you may want to geocode it to be able to get coordinates to mark a destination for delivery. So Radar in general, we're reinventing location. We're very, very focused on privacy. We don't want to ask for more than we need to. So a lot of our tools and capabilities only require foreground permissions. We also provide access controls on our dashboards for visibility, to sort of control the retention of data, to control who has access to see location. And our SDKs provide much better accuracy than typical native client geofencing, where we have our own platform where we can pass the coordinates out to our platform, and you could have geofences of different types. They could be polygons, could be circles, could be isochrone, sort of route-based geofences that could provide, up to like 5-meter accuracy. We also support beacons. So I know in a lot of these operational use cases where maybe you're tracking the loading of product, you may have beacons that you may want to pull signals and identify, how much time someone was in each spot. So we provide beacon support there. And from a developer experience, like we allow you to develop on what you prefer to use. Like we support not only native, but capacitor, React Native, Xamarin, whatever you're building your solutions on, we'll be able to support and provide the same full feature set as you would expect. And it's very simple, as you'll see sort of as Pal dives into the code, that it only requires a few lines of code to power something like a trip tracking. So this is how radar works, right? You've got devices, you've got phones, you've got laptops, you may have GPS tracking equipment, leveraging our SDKs and our APIs, providing insights like the GPS coordinates, and then leveraging trip tracking, the geofences that you may have established places, which are basically our own geofences or our regional barriers, and or beacons. You can then be able to provide these signals back to your integrations, to analytics, to power dashboards, whether that be dispatch, whether that be inside of a store showing when someone's expected to arrive so that their food is hot and fresh. A lot of flexibility there to be able to activate based on these signals. And sort of wrapping it all, radar isn't as a location OS in a sense where we provide a dashboard for managing geofences, making bulk edits, doing synchronizations, whether it be nightly or bulk imports, to make it really easy. We also provide place matching, so you can provide coordinates for those locations and we'll actually fix them and even create actual polygons that are around the actual buildings. And we also provide some dashboards. So if you haven't built something yourself and you want to be able to track trips to a location, you can see them real time in a dashboard on an iPad or on an Android device. So today we're going to really focus in on trip tracking, which is why we have Pal here. Basically tracking trips from point A to point B. Basically SDK, pulling live location updates, providing ETAs back to that trip, generating events at the right time. When is someone considered approaching, when they should be arriving, as well as providing access to trip APIs to be able to pull trips and populate this information potentially in your own dashboard, your own view, or to a consumer app, as well as connecting that back to whether it be our analytics, where we have some views to be able to monitor and track performance of trips, or building your own. All of this is powered by our SDKs, and as I mentioned, privacy first, super developer friendly and easy, and then unparalleled accuracy, just because we've been doing this for a while. So we definitely believe in what we do. So I'll pass it on to you, Pal, and you can jump in.
Thanks, Arek. Cool. So now I want to kind of step through how you would go about building a delivery tracker using radar tech. And we have pretty limited time here today, but the goal is to walk through an illustrative example using iOS to see what kind of pieces come together to make an example app like this come to life using radar components with very little lines of code and little time kind of needed. And the skeleton, so this is a preview of the example app that we'll be kind of stepping through. The UX for the skeleton UX as part of this app will be for a user to dispatch upcoming deliveries and monitor progress on them, using live location tracking, they will receive progress notifications and see ETAs like displayed on the bottom of the screen there on the right, and can also track the progress on a map. And we'll step through kind of what needs to come together to build an app like this. Just as an illustrative example, a very kind of simple example, but these are the building blocks you can use to build any sorts of customer experiences and build that really great location tech using radar. There's, as a note as well, this stepping through this tutorial is also available in a full written format in our tutorials library in the radar documentation page. It's available through this link or this barcode here. And the source code for some of the things that I'll be walking through are available through that GitHub link, also linked within that tutorial, if you want to kind of check it out after the session. So the first step to kind of go about using any of Radar's tech is to create your Radar account. It's pretty straightforward to sign up for an account. It's free to sign up for one and play around with the platform. Once you do that, you'll find your API keys on the Get Started page in our dashboard. There's a few sets of API keys. We have test and live environments. Test environments are for developers and builders to play around and use in the development process for the application, and then live keys are for productionizing your application. So in this case, we'll be using the test publishable key to put it into the iOS app and utilize the Radar SDKs. So the Radar, once you've created your account, you'll have access to this Radar dashboard, and I'll walk through some of the highlights on this dashboard quickly, and I'll need to change the tab we're looking at really quickly. So give me 1 second here. There we go. So this is what the Radar dashboard looks like today. You can go to the home page to see all sorts of tools to get started. There's some quick kind of start tools. There's an example app called Toolkit that's available on the App Store. You can download it and get started with Radar right away without having to write any code as well, if you just want to kind of see location tracking happen as you step around in real life and look at what sorts of events you can generate. And there's also links to kind of what's new with Radar here. Some of the other things you'll find in our dashboard are pages to manage things like your geofences, your beacons, your segments. And if we kind of zoom in to any of these, in this example, we have a geofence here for a Walmart, and we offer polygon geofences, circle geofences, can be kind of custom drawn to fit your needs, even isochrone geofences as needed. So this is where your geofences home is, and as we'll talk about, geofences are the destinations to most of our trips, and we'll kind of go through that in a little bit more detail in a bit. There's other tabs here, like you can see the users that you're tracking, and for any users, you'll be able to see that they're stepping through different locations as we track those locations, and then make those locations actionable by generating events on them. Things like entering and exiting geofences, approaching a trip destination, arriving at a trip destination, etc. And you can also see events in this tab all in one place. So there's a lot of different context types here, but the one we're zooming into a little bit more for this webinar is trips. And for trips, this is a page on our dashboard that shows you all the current and past trips with this project. You can step into one of these trips and view them on a map, see all sorts of information about this trip, look at what sorts of events were generated for the trip. And finally, there's a simulate tool where if you can actually start trips or step around to see real kind of track locations, and if we do start a trip here, you can see the events that this would generate in real time. So this is just a quick overview of our dashboard. There's also an explore page if you're interested in some of the API offerings like geocoding, search, and routing to see how this might fit your needs. But we will now step back to the tutorial and continue now that you have a radar account and access to our dashboard here. So here, the next step would be to go ahead and create a geofence within the radar dashboard. We looked a little bit at the Manage Geofences tab, and there's a Create button within that Manage tab, which takes you to different options to create a geofence. So this is the first way to create a geofence is through the radar dashboard, but you can also create geofences programmatically, which is what we would likely do in a productionizing scenario for something like a delivery application, where a delivery address can be geofenced programmatically using our API, and it can also be set to expire automatically to make it transient. And one more thing I'll mention is an upcoming capability for trips is the ability to create trips even without a geofence if you want to get started quickly using a coordinate or an address, and that'll simplify the step a bit more. But for geofencing in general and for this tutorial, you can follow these steps to go create a geofence through our UI, and we can move on with the steps here. The next step here would be to set up your radar SDK. Since we're using iOS and Xcode, we use a dependency manager like CocoaPods. Once this is set up, we can initialize the radar SDK in our application, and using the API keys that we grabbed from the first step. And this will make the radar SDK accessible within your application. And then you can use all of the SDK methods to start and stop trips and start and stop tracking and all of those. So the next step here would be then getting location permissions from the user of the application. With Xcode here, there's a step to add location usage strings. And what this means is when you prompt location permissions from a user, they see a message for what you'd be using that location for. And the way we configure this is in the info.plist file, which looks something like the screenshot at the bottom. And we add a new property with this key called NSLocation when usage description. In this case, we're requesting foreground permissions. As Arek mentioned, we're a very privacy first company, and foreground locations tend to be sufficient for delivery tracking needs for an example application like this. And we can put in the value as necessary for the use case. And once we do that, we can then go ahead and call for location permissions usually in the app open flow or somewhere in the beginning, and we skip that step as well if we already have those location permissions. And the pop-up on the right, it would be what the user sees in that case. So once we have location permissions from the user, we can get into the trip flows and in the appropriate place where you would want to start a trip, where in this case, it would be with the skeleton UX, when the dispatcher starts a trip, starts a delivery, we'd want to start tracking progress on it and start a trip. There's a few necessary components of a trip, as you'll see in the code snippet here. The most important ones are the external ID. In this case, we use a UUID for simplicity, but this should map to any internal identifiers that you have for a delivery or whichever object you're modeling with the trip. The other, to specify the destination of the trip, we use a geofence tag and a geofence ID to uniquely identify geofences at radar. And these two specify the destination for this trip, and that's what the progress will be tracked towards as the user makes progress. Some of the other useful fields when creating a trip are mode of transport, which makes ETAs more accurate, and you can set this to something like car, walking, bike, etc. And the last one here is metadata, where you can set any sort of custom field and custom information that you'd want to store and associate with this trip. At the end of this setup, we take this trip options object and pass it into start trip. And this creates the trip and starts it on the radar side. One step here would be to also ensure that we are tracking the user around at the time that we are starting this trip. And in the older SDKs, we would go ahead and call something like radar.startTracking. But with the new SDK that we shipped in the last couple months, there's actually a second argument to radar.startTrip, which allows you to pass in tracking options and start tracking just for the duration of that trip. But that leads me to the next slide on tracking with radar. And tracking is needed for these trips to consume location updates and reflect progress. It is technically possible to progress trips using our API and can use that for different use cases. But in this case, we would want the trip to update automatically as the user is tracked and makes progress on the trip. Tracking with radar is very simple to get started with using our tracking presets, but it's also fully customizable, and you can customize any of the many fields and tuning parameters that we support with tracking. For trips, we usually recommend the continuous tracking preset as a trip which gives you location updates roughly every 30 seconds, and that's usually the frequency we'd want for a critical period like a trip or a delivery that's happening. But there's trade-offs with things like battery drain, which allow you to, which you can customize the tracking options for to achieve your desired balance. Then we can simulate, we can also simulate a trip between test locations using the mock tracking method. So this is part of being developer first platform. We don't want you to have to walk around every time you need to sort of test the sort of application. So you can use a mock tracking application to mock tracking method to deterministically have location updates come in and see the trip update and events come in and go from there. The next step here, once the trip is in progress and has made sort of made progress in the journey, we'd want to complete the trip once the delivery is complete. And in this case, we use the arrival of the courier at the destination geofence as a signal for when the delivery is complete. But we can alternatively use a number of things like a user action, like a complete button. We could use a destination geofence exit event. We could use a buffer time after an arrival, so completely customizable to a customer's needs. But we would complete the trip once the delivery is complete using radar.completeTrip. You'll also see that we have radar.stopTracking in this older SDK's example code. But as I mentioned earlier, we have that second parameter of tracking options when you start a trip. And if you do include that, tracking will automatically stop after a trip if it was not active before the trip. And moving on, so this, now we have all the components to start a trip while a delivery happens, track progress, and complete the trip when it starts. And now it's really about building a user experience using all of those components. In this case, we use a simple listener to start adding notifications and then a map. This is completely flexible, and you can use all sorts of events, combination of webhooks, and build a UX wherever you'd like a web application, mobile application, or wherever would be the right place to build user experiences for your use case. In this case, we request notification permissions. We set up a notification manager, and we start sending notifications with trip events. So trip events update on progress, like approaching a trip destination, arriving at a trip destination, and we're sending notifications here with the appropriate titles. And the last step here is to get to what the screenshot at the beginning looked like, and that's the ETA tracker screen. So this is using the map components from iOS, but we're able to zoom in and out of the correct region that the user's in and move and update the current location pin as the courier makes progress on the delivery based on the radar update location events, update trip events, which will update the trip every time there is a location update on the trip. So with this screen, we can fully see this would be the resulting experience to start a trip and monitor progress on our example app here. So this is a very simple UI with no animation, but you can build user experiences to whatever needs you have with the same building blocks here. But we can see the notifications come in. The mock tracking I used has the location updates sort of far from each other, and that's why the pin's sort of flying through San Francisco here. But yeah, that's the example trip tracking application that we built, and I'll pass it off to Arek to talk a little bit more about how our customers use trip tracking today.
Cool. Thanks, Pal.
I will now reshare the slides.
Cool. So having done this for, as Judy mentioned, for about 3 years here at Radar, working with a lot of logistics, QSRs, and even retail customers, everyone has different KPIs and different outcomes that they're trying to improve or further operationalize with something like a trip tracking. What we've noticed, like typical high-level trends, is from a delivery optimization perspective, the big goal is reducing product pickup and load times, right? Time is money at the end of the day. So reducing the time to get an order loaded on a truck and efficiently out and to the customer is definitely a high priority. Other things like basically servicing the wait times and even showing optimal pickup windows for those that are going to pick up a load or pick up a product so that they can increase throughput throughout the day. And there's not these queues that are forming at any one of these locations. And then obviously, sort of like with the app that Pal was walking through, providing delivery status updates and ETAs back, whether that be dispatch or to a customer, so they know, hey, my Amazon order is coming and it's going to arrive in the next 2 hours or 15 minutes, so they can be prepared for it. On the pickup side, this is typically where we see in the QSR space or BOPIS, buy online, pick up in store, where trip tracking is used sort of from a order fulfillment prioritization standpoint, where whether it be the ETAs of where all the customers are that are traveling to go pick up an order, or providing the signal of when they're just far enough away so we have enough time to pull it all together and get it ready for delivery. That's a high priority. And for the QSRs, it's more around, hey, let's fire the order considering the make time and the current ETAs at just the right time, so the food's not sitting around too long and getting cold, or that they arrive and they got to wait in the parking lot for a while until their food's delivered to them. And we're also seeing very interesting workforce management scenarios where, not only tracking trips for pickup or delivery, but it's more for tracking things like appointments, seeing where people are for a scheduled appointment. Are they going to be a no-show? Are they delayed? And really taking action on that to either remind them or just close out that scheduled appointment, knowing that they're way too far for them to arrive in time. So those are some of the ways our customers use trip tracking, but there's infinity different things you can do with trip tracking and the flexibility we provide to be able to power any sort of use case related to tracking.
Cool. With that, I think back to Jody, and I think we'll have some time for Q&A.
All right. Awesome. Thank you guys so much. That was amazing. It's just incredible to think about what's possible in today's world with technology and connecting the digital and physical worlds together. So thanks for sharing all of that. We do have one question so far that has come in. I will say if anyone else on here has questions, feel free to send them in now. If not, we will follow up with you afterwards if any other questions come up. But in the meantime, let's get to this one that has come in. You guys mentioned turnkey integrations. What types of integrations does Radar work with today?
Yeah, I can take this one. So, we work with, we have a lot of turnkey integrations with CDPs, marketing automation solutions, analytics, whether that's behavioral tests, UI sort of analytics tools, or analytics bringing in all these types of events to determine, different segments to build out for, whether it be campaigns, whether it be for just bucketing people in certain journeys, whatever that may be. So a lot of turnkey integrations. You can find those on our website under our documentation integrations. But we also support webhooks that gives you the flexibility to send our events basically anywhere and be able to take action on those. Anything you want to add, Pal?
No, I think that's perfect.
Awesome. All right. Well, we don't have any more questions right now. So just want to thank everyone for tuning in today. Stay tuned for future technical talk sessions. We'll try to put together a theme each month or every other month to continue this momentum and continued learning. So thanks again for joining, and we'll talk to you all soon. Thanks, Pal and Arek.
Thanks all.
Yeah. Bye, everybody.